EE304, and this is lab project number 1 using LabVIEW and MyDAC. And what we're trying to do is we want to design a circuit that has a 3.9K ohm Thevenin equivalent, and we want to take a few measurements of that circuit, and ultimately in the end we want to prove the max power theorem happens when the Thevenin resistance equals the load resistance. And what I like to do whenever I'm trying to design the circuit is I like to get on multisim on the computer, and I like to try a variety of different resistors in order to get me close to what I need to be. And so that's what we've done here. And through this laboratory, we're going to find our open circuit voltage, and we're going to find our short circuit current. And you can also find the Thevenin resistance by dividing the voltage by the short circuit current. Like I said, on step 1, I like to use multisim to take and get me close to where I need to go. And from there, since we're using MyDAC and MyLab in conjunction with each other, you've got to plug into your computer through your MyDAC, and then you've got to sensitively place these together. Now you've got a connection. And I've already got the circuit configured on here to save time. Basically what this circuit is, this circuit is a circuit from figure 2 that's in the laboratory, and it's already designed on the circuit board. Once we get close to what we want on multisim, then what I like to do, the next thing we need to do is to actually measure all our resistors prior to putting them into the circuit. And as far as getting this MyDAC ready to go, black goes to your black common terminal, red goes to either side, it doesn't matter. Now in order to get this ready to go, you need to get on the computer, and you need to create a DAC assistant, and you need to go to generate. And once you go to generate, you need to go down and you need to perform pretty much exactly what looks like this. I've already got this set up to save time in this experiment, but this is pretty much what your screen's going to end up looking like. This one is going to be taking readings, and this one here is going to be generating power, since we've got 9 volts on our breadboard here. We've got 9 volts on this, so we need to get it down to 5 because that's what the circuit requires. So we're going to have to do that through the LabVIEW software. Now, step 2, to record resistors, the actual values prior to putting them in the circuit. What you need to do is come to the LabVIEW. You need to select your ohmage, and it's going to default to 20 mega ohm, and you need to come down to 20K ohms. Then you need to hit run, and prior to putting these resistors in the circuit, we need to measure their actual value of each resistor that we have chosen. Now, like I said, I've already got this configured as far as in figure 2 of the lab. Now, in order to generate 5 volts, like I had said before, we got to do that through the LabVIEW, and you need to hook your voltage output control up and put a 5 in there, and then you can come up here and let this run continuously. And let me bring this back up. We're going to go to voltage because we want to measure voltage and we want to measure current over the entire circuit. Now, we always want to make sure to readjust our ranges to where they need to be. Okay, and now with this being done, the way this is set up here, I'm generating a voltage of 5 volts through the AGND, that is my ground on the output side because of what I've selected through DAC Assistant, and the AOO, which would be these two terminals right here. These two terminals right here. This is the configuration of the circuit. This is a jumper wire at node 1, and I think this is node 2 and some other things here. And this I just for demonstration purposes. Now what we're going to do is on each one of these we're going to measure the voltage across it, and we're going to measure the current through it. And we're going to take and we're going to write all those values down, because in the end it is going to, we're going to get our power by summing up all of those resistors. We're going to get our power in. And now in order to next step 5 here, we're going to find our open circuit voltage. And what we do by that is actually, we're already set up for that. We take the load off of the circuit and we measure between the last resistor, which is the positive side, and we measure the ground, and that's going to give us 0.46 volts. And to find the short circuit current, what we're going to do is we need to short what will be R4 to ground. And then we're going to get on LabVIEW and we're going to change our settings to amperage, and we're going to go to the 200 milliamp range, and we're going to measure between that R4 and positive, and that's going to give us our 0.13 milliamps. Now we can take both of those and we can take and we can figure our Thevenin equivalent by just dividing our voltage by our short circuit amperage, and that'll give us our Thevenin. But there's another step in here that the lab is wanting us to perform, which is finding the Thevenin equivalent resistance directly. And the way we do that is we take the voltage source out of the picture. You're going to short your voltage source pretty much. You're going to read across your output terminals A and B, and you're going to get in here and you're going to change back to your ohmage, and you're going to go back to that 20k ohms, and you're going to read between points A and point B, and that is going to end up giving you a 3.8 k ohms for the resistor values that I've chosen. Last, we're going to try and prove the maximum power transfer theory. And the way we're going to do that is we're going to choose 10 different resistors and from 0 to 5.6 k ohms, and we're going to see how those values match up as we come through there. First thing you need to do is, in the first part of the demonstration, is you need to measure whatever values of resistors that you're going to use. You need to measure their actual resistance and record it prior to putting them in the circuit. Once you get those measured, next thing you're going to do is you're going to turn on, you're going to supply power back to the circuit as before with the 5 volts, and we're going to place each one of the new load resistors into the circuit. As so. And then we're going to measure current, and we're also going to measure voltage across these. Actually, your voltage is already given by your Thevenin equivalent voltage, so really all you're really concerned about is your current through these. Or vice versa. You can take the current and you use the equation R times I squared, and that will give you your power. And what you're wanting to do is you're wanting to see which value of your load resistance meets your maximum power transfer theory. And you need to know the power from each of the 10 resistors, dissipated from each of the 10 resistors that you choose to do this. Step 10 that I've got wrote down here, we're going to collect all that data and we're going to take a look at it, and we're going to see what's the best value for the load resistor for the maximum power transfer. And we want to keep in mind our error equation, which is what you got through your experiment minus what you got through your theory divided by what you got through your theory times 100. And if you fall within plus or minus 10% of that range, I would say you're safe to say that you've conducted the experiment fairly well. That's all I got. Thanks a lot. Again, Brian Morrow from EE304, MyDAC, and LabVIEW experiment number 1.